This is the terminal. Most people know it as the black box where you run commands and that's it. Little think of it much more of it than just a glorified text box. But I was wondering, can you render in 3D using the terminal? How would you even attempt such a task? Since the terminal can only display text, I decided to use the half-block Unicode character. Since this Unicode character is still technically text, most if not all modern terminals should be able to render it. Great! Now let's add some color to this. I decided to use the ANSYS color codes as my way of coloring things, as they are well documented, easy to use, and most terminals support this. Now bada bing bada boom, we got what is effectively a pixel in which we can change the color of. We are basically halfway through at this point. Now all we need to do is render everything in 3D. This is a lot easier than it sounds, but let's take this one step at a time and draw some lines. I decided to use the Bresenham algorithm for line generation. It works by incrementally deciding which pixel is closer to the true mathematical line at each step. This is both fast and accurate as it avoids the dotted lines seen in other algorithms. Great! Now that we can render lines, it's time to render triangles. Triangles are the basic backbone of all computer graphics, and if we can render them, we can render anything. Think back to geometry class. What is a triangle? Well, it's a shape that has 3 points and 3 sides, with interior angles that add up to 180. That's just 3 lines that meet at 3 different points. Triangles are really simple to draw. Here they are rendered in the terminal. Great, but how do we fill them in? As cool as wire triangles are, I'd like to fill them in. What we could do is convert all the math into fixed point arithmetic, which is basically representing floating point decimal values as integers so that the math is way faster. Then we can split the screen up into 8 blocks and discard blocks that don't include our triangle. Finally, from there we can loop through the remaining blocks and fill in the pixels that are inside all sides of our triangle. Bada bing bada boom, that's our filled triangle. Now in my opinion at least, we're in the home stretch. All we need to do now is some matrix transformations to convert 3D coordinates of our model into 2D coordinates needed for actually drawing it onto the terminal. The approach I took is to get rid of the Z coordinate and just keep the scaled X and Y coordinates so that we can display this on the terminal. This way the parallel lines stay parallel. This is called orthographic view, and I chose this because it is really easy to explain and also stays in line with that 1990s computer-aided design feel you get from those old demos. Finally, by applying these rotation matrices onto each point, we can rotate our object. Great, here we are. We have a rotating wireframe view of a teapot. But this still feels off. 3D isn't just shapes, it's also about lighting. These wireframe meshes are ugly, so let's add some basic lighting. What we can do is get the dot product between the normal of a triangle and the direction of the light source. This is equivalent to the cosine of the ray that hit our triangle. Now we have a way to tell how intense a triangle is getting lit. From there we can convert the 0 to 1 scale into 4 different shades of gray, and finally we can just tell each pixel what color it should be. And there we go. We have a fully lit teapot. See, that wasn't too bad. Remember, this is all in the terminal. Just a few minutes ago you thought this was a magic black box full of only text. Now this magic black box is rendering everything from a bunny to Buddha himself. We did all of this without any dependencies, so no OpenGL, Vulkan, or Metal. Purely using text and some C++, we were able to render this. Imagine how cool it would look on an Arduino, or maybe a toaster screen, or perhaps even a pregnancy test. This is very portable code we wrote here, and look at all of the cool things we can render with it. After all that hard work, I think we deserve ourselves a 30-second montage.